Okay, today, not today, but, well, it is today. It may sound like this is the first thing I'm talking about today, and as you know who we're sitting here, this is the second thing. Remember, unequal cell sizes and empty cells. Unequal cell sizes and empty cells. Okay. Most designs assume equal ends. It's just how it works. You'll note that I'm always showing you that. It's like, what's n equal? And I don't say what's n equal here, and what's n equal here, and what's n equal here. I just say what's n. It's best if they're the same size. It makes analysis, it makes post-hoc tests especially a lot easier than the same size. Except for the very simplest kind of design, like one-way analysis of variance that we started back when we were in that other classroom, and I used to swear a lot because the gear wasn't working. And I think I threw something at one point. No, I almost threw something. I stopped myself. Because I have a filter. Hard to believe, but it's in there. We talked about that, and we had, you get about equal cell sizes, they're no big deal. But most designs assume equal ends, and considering everything, it's about variance, and variance depends on n. Think about how, when you calculate a mean square, which is the variance, it's always got something about the observations minus 1, the total. Yeah, it's about variance. Variance depends on number of observations. Best if we keep that the same throughout all our groups. Let's say you don't have equal ends. What do you do? Well, the first thing you can do is ignore it, which you can do without too many problems as long as they're very close to being the same size. Okay? So that actually wasn't one of my points, but this is what most people do, is they just ignore it because it's like you got 12 subjects here and 18, and 13 here, and 12 here, and 12 here. That's fine. But you know what? If you've got a 2 by 2 and you've got 12, 12, 12, and 13, go collect 3 more freaking data points. Seems to me. You can estimate the missing values. Well, you could, I guess. Yeah, I guess you could. Use the mean. So maybe use the mean as the median, perhaps, and measure central tendency. In fact, SPSS, you can deal with missing values in a lot of ways. One of them is to say, you can tell it to put the mean in. Do you want to put the grand mean in? Do you want to put the mean for A1 or whatever, or mean for A2, whatever it's missing? Or do you want to have, do you think there should be, I don't know. It's not actually an easy thing to do. At first blush, it's like, yeah, just put the mean in. Yeah, but the grand mean or which mean? I don't know. And there's a lot of different ways to mathematically do this estimates. It's not like it's wrong to do this. I would prefer you just either ignore it, put it, or just go collect a little bit more data. But like I said, do you include the interaction or not? Because if there's an interaction, let's just say it's a 2 by 2, just something very simple, and you're missing one data point, and it looks like there's an interaction, but what if you thought, well, maybe that one data point would take the interaction away or something? So what do? I don't know. It's a tough call. It's a very tough call when you have unequal cell sizes about what you're going to do to fix them. But no matter what you do, you've lost degrees of freedom. So when you add in an estimated value, which is not a bad thing, I would instead go collect more data. But if I couldn't and I really needed equal cell sizes, I might estimate them, but I would keep in mind that if I add a value that I've just estimated, it's not like that increases my degrees of freedom. So let's say I had 4, 4, 4, and 1. So 4 subjects, 4 subjects, 4 subjects, and 1. So right now I've got 13, but what I'm really hoping for is 16. So I estimate 3 values to make it 4, 4, 4, and 4. I could do that. It's not ideal, but I can do it. But I don't now have 15 degrees of freedom. I still have 12 because I made those other ones up. There was no freedom in those numbers. I made them up. The numbers were not free to vary. So when I say lost degrees of freedom, you haven't really lost them. You just haven't gained any when you estimate. And I think intuitively that makes a lot of sense. I can tell you, though, that I once, when reviewing a paper for a journal, saw that somebody had done some correlation that didn't work. Like, it wasn't significant. So what the authors did is they said, we then used the following procedure, and I forget what the procedure was, to estimate another 20 values. That's fine. That's perfectly fine. I guess it's a little weird. Why don't you just go collect more data? But fine. Then they did the analysis, assuming they gained all these degrees of freedom. No, that is wrong. Now, I caught it. I was one of the reviewers of the paper, and I hope I wasn't the one who caught it. I can tell you that they clearly weren't trying to game anything, like to get some advantage by cheating, because they were transparent about what they did. They just didn't know what they were doing. So these authors had done something they'd heard of, which is estimating, missing values, but then they said, so that gives us more degrees of freedom. It doesn't. So they didn't quite know what they were doing. And I was very tempted in my review to write something very snarky, but you try not to do that because it's not really nice. So instead I said, just refer to it, and I just referenced the statistics book, and I said, please don't do this, and you don't get the extra degrees of freedom, etc. I'm only snarky in reviews to my friends. Like, it's a friend of mine's paper, I'm reviewing it, and they don't know it's me because it's all blind. Save your blind jokes. But it's all blind, so they don't know it's me. But I know who the author is. And I'll make a joke comment. Because why not? Not everybody, if you don't know me, you don't know that I'm just kidding when I say something. You always have to be careful. Reviews now for NSERC, the National Science Engineering Research Council that funds research, they actually now say no sarcasm, please. And I like to think that I made that happen. So you've lost degrees of freedom, or at least you haven't gained them by adding extra numbers, which should be intuitively just obvious, seems to me. There are other ways to do this. So most of our analyses that we've talked about, in fact, everything I've talked about up to this point, we use something called type 1 sums of squares, which should tell you something. There are more than one type of sums of squares. Type 1 sums of squares are weird. Even though they're intuitively appealing, type 1 sums of squares that I've been showing you, sum of this minus this squared divided by this, or not divided by, because it's sums of squares. When you calculate those, if there's an interaction, and you have unequal cell sizes, they can make it. There's a problem with the estimate. There can be a problem with their estimate. I'll just say that with the way how they estimate variance. And if the ends are equal, by the way, for all the groups, they're fine. They're perfectly fine. But if the ends aren't equal, it depends on what order you do the calculations in. What? It just does. You'll see why when we talk about regression, because we'll talk about type 1 and type 3 sums of squares. The point is, this can be an issue. The nice thing is, when we do I've taught you with type 1 sums of squares because that's intuitively correct. And it still is correct if the number of ends are equal. Our software doesn't use type 1 sums of squares. So when they're unequal, they're bad. If they're almost equal, as I said, they're probably going to be close to correct. Now, type 2 sums of squares, you figure there's going to be, if there's a 1, there's going to be a 2. They're good if there's a missing value. So that's good. So they can actually deal with missing values, type 2s. Type 2s do a thing where they account for incremental amounts of variance. So you put when you type 2, it says, okay, we've accounted for all the A. How much extra comes from adding B in? And again, we'll talk, this will make a little more sense when we talk about regression. But the way they work is just somewhat different. So, and they're fine if there's no interaction. But if there's an interaction, again, there's a problem. Even if there's unequal cell sizes. They're great for unequal cell sizes unless there's an interaction. Okay.
So when we were talking about Latin squares, I assume any sums of squares you get out of your analyses for that would be type 2 equivalent.
No.
Nope.
No, let's. You're overthinking it.
Oh, yeah.
You're overthinking it. So your type 1s are what, when I show you things like the sum of column means minus the grand mean. Those are type 1 sums of squares. Type 2 sums of squares, and type 3 sums of squares, and type 4 sums of squares, yes, there's still 2 more, are all done with matrix algebra. And I'm not going to go into matrix algebra for 2 reasons. 1, I am not very good at it. And 2, it really is literally beyond the scope of this course. That's graduate level stuff. I'm not going to worry about that. You really don't want it. Anybody here actually know how to do matrix algebra? Did you do it in high school maybe? Or university math? It was just me. And I did it in graduate school. And I've never done it before. It's great. Oh, you've done it?
I think we touched on it in one math course.
Okay.
But just a little bit.
Yeah, just a little bit, right? I have my PhD stats here, because we had a course in grad school, in master's and a course in PhD, and we got to the PhD, he's like, so you all know how to do matrix algebra? And we're all like, no. Oh, sorry, there was one guy that did. And then so he just he handed us all like a 3rd-year math textbook, photocopied chapters. Well, I don't have to do this by next week. Okay, that sounds great. I mean, we did. I can't for the life of me do it anymore. I could probably still invert a matrix that was like a 3x3 or something, but beyond that, it was not fun. Now, type 3s, which is in fact, if you don't know there's a interaction or not, type 3s are pretty good. They actually, you use type 3s, you're safe. If you got some missing values, unequal cell sizes, and in fact, our software uses type 3 sums of squares. Even though I've taught you about type 1 sums of squares, you say, Dave, that's not fair. It doesn't really matter, because if you have equal cell sizes, type 1s and type 2s and type 3s are the same. So they actually come up with the same solution. That's beautiful. So that's not a problem. So I can teach you type 1s, because that's how analysis of variance was developed with type 1 sums of squares, and also because I think it's intuitively the most pleasing one, which is their deviations of scores from means. But it has this assumption that's built in that the n's are the same size. And if they are the same size, the type 1s, 2s, and 3s all come up with the same solution, which is beautiful. I just noticed that I had some notes there. I keep going back and looking, and the only thing I have written there is yay. So I'm supposed to be very excited that they all have the same size. So our software uses type 3s because it's a nice, it's a way to make sure if there are unequal cell sizes, it's still fine. Okay? So that's good. So in fact, if you look at the output from, you know this from watching the videos that I made about SPSS, that when you do anything beyond a one-way analysis of variance, you're using something called general linear model. That's the procedure. You're not using the compare means procedure. And in SPSS, and when it prints out, it actually says type 3 sums of squares. Right? You can actually have it give you the type 1s, 2s, and 3s, 1s and 2s as well if you want. You can choose those. Those are options, but nobody ever does. We all use type 3s because frankly they work. So we're going to taught you from type 1 sums of squares because they make the most sense and that's where analysis variance comes from. But when the machine does it, it uses type 3s because that it gives us an extra bit of safety if we have unequal ends. Okay. So you can see here, this is this is an analysis I did using type 1, type 2, and type 3 sums of squares. And you can see that we get somewhat different values because we have different numbers of subjects per group. This is just something, I just want to actually double check what I do have here in my notes. Oh, nothing there. I just made up some data and ran it, a type 1 analysis, a type 2 and type 3 with different ends. So there's different numbers of subjects per group, and this is, what's that look like? What do we got? We got A, B by A, and A by B, yeah. Okay, and this is telling us that this is the A effect, this is the A effect given a B effect, and A effect given a B effect in interaction. Doesn't matter. A, B, A by B. And you can see they're subtly different. So I'm just trying to prove to you that I'm not just making this up, they come up with different solutions. So they're subtly different. Now, oh no, there's a fourth one? These work with empty cells. We've got no data in one cell. So this would be like if you had a 2 by 2, but then you had a missing value. And I'll show you an example of that in a sec. And they'll come up with a solution. The problem is they will not come up with a unique solution. Or they'll come up with a unique solution, but it's not the only solution. Let's say that. Because there is no unique solution if there is a whole cell of your analysis missing. Let me show you what I mean. What goes there? These are going to be cell means. So there's 4, 2, 2, and whatever. So this is like we have one of those things that I say break down the table, is there main effect of A, main effect of B, etc. What should that be? Oh. So what should this be? A lot of people say 4 because they like symmetry. Well, there's more 2s than 4s. Maybe it should be a 2. Maybe it should be 1,000. I don't know. Maybe it should be a picture of a wheelbarrow. There's no solution to this. I have no reason to believe that this should be anything or not. But somehow I've got no data here. How would you analyze this experiment? So we have 2 levels of A, 2 levels of B, but somehow, because we weren't, I don't know, paying attention, we never got anybody in the group A2, B2. What would you do? Let's do a little thought experiment. So instead of guessing what the number should be here, I don't know what it should be. Like I don't know. I can't make up. I can make all numbers are possibly correct. What's a way to analyze data like this? What do we want to do? We want to compare 3 means, right? How could you compare 3 means? Anybody have any thoughts on how you could compare 3 means? Sure, go ahead and stick your hand
I didn't actually, but I was
Okay.
kind of having a thought.
up. Okay. Other thoughts before I make it right?
Crazy idea of using one way ANOVA.
Yeah, that's what I do. It's literally exactly what I do. Or I go, actually, the first thing I do is I go collect more data. the first thing it'd be like, oh shit, I forgot to collect A2, B2, I better go get some subjects and collect more data.
Yeah, pressure flow.
But if not, yeah, look, am I gonna find an interaction with a one-way ANOVA? No. That's not gonna happen. But I don't have any numbers here, so I can't guess if there's an interaction or not. This is gonna tell me if there's a main effect of A or B. No, it's not, but it's gonna tell me at least the three groups differ. And that's, I'm gonna salvage it that way. That's what I would do. I mean, the first thing would be to try to get the data, because frankly, if we're interested in the interaction, let's go see if we can find it. But if I can't, what I'd do is I would do a one-way analysis of variance between three groups. It would be less than ideal if I was actually looking for interaction, but it also just would be life. Now, I have run into this in my life, not with my own data, but I told you the other day about one of the ways you can make a little money in grad school if you're into statistics. If you're good at it, is you can rank yourself as a statistical consultant. So there was a lab, it wasn't in the psych department, but there was a lab in the building I was in at the University of Toronto. And they had collected some data, and they were using a statistics package that I knew. It was actually the one written by my stats prof. He had written his own stats package. It was really nice, actually. And they were using his thing. They were actually the eye bank. So they collected corneas and things so people could get transplants. So it was weird. At our building now and then, someone would show up with a cooler and you'd think, oh, that's a cooler full of human eyes. That's interesting. So they're doing this experiment and they ran the study and they didn't know how to analyze the data. And I was just one floor up and I got a phone call from my stats prof and he actually said, is there anything for you? You can charge them like $200. So it'll take you 20 minutes. Okay. Hi, I'm Dave. Tell me what you designed. The guy tells you the design. And I said, okay, cool. And I'm putting everything in. And I said, it wasn't quite this simple. It was more like about a 5 by 7. And there were like 3 cells completely missing. And I said, well, there's nothing here, nothing here, nothing here. Is that true? He said, well, yeah, there's nothing there. I said, well, you can't just say there's nothing there. That's not a thing. He said, well, you know, we couldn't. I said, could you get any more? I said, now, so what are we studying here? I was going to say more subjects. I said, can you get more subjects? He said, what do you mean? I said, eyes? He said, yeah, well, no, we can't. I said, well, and he actually said, couldn't we guess what those were? I said, well, and I literally gave him this lecture. I said, what number should be there? And he looked at it, and he got this sort of, he said, I don't know, like 7. I said, why? He said, well, it sort of looks like, I said, no, that can't be a reason. Because I could say 1 million, and that would also be a possibility. I said, you know, unless you get more data, I said, there's a way to do this. We can compare all these groups, but it's not going to tell you if these two things act together. And he said, why not? And I said, oh, so I gave him a little, showed him some math. He's like, no. So when you get more data, this is easy. Just get if you can get them. And he said, okay, well, thanks a lot. I said, yeah, that's $200. So he wrote me a check. So I can say, well, you didn't do this properly. It was good. Okay.
I was gonna say, I mean, that's a much bigger design than what we're looking at on the
of course,
surface.
yes. Yeah.
If you, not that it works for what they wanted in the first place.
Yeah.
But if we did that one-way ANOVA, is it like when we do repeated t-tests that the alpha will inflate? Like
no, because the nice thing about a one-way ANOVA is that it doesn't care about the number of groups. So it would be okay. I asked a bunch of, it wasn't quite as short a conversation as this, but it did take about 20 minutes. That's about it, because I could explain to the guy how this didn't work. And what he did, he just didn't do it right. And he actually turned out he was too ambitious and he had too many groups. I said the only other thing we could do is we could kill this whole column and kill these other 2 rows, and I believe that's what he ended up doing. So we can kill these, but you're not going to get all the answers you want, but you'll at least get an answer closer to what you're interested in. And that's, I think, what he ended up doing. And then he paid me $200. You know. So I believe I spent on chicken wings and beer. So I haven't changed that much. So don't have empty cells. You can have unbalanced designs, they're okay. It's better if you don't, but our software takes care of it because it uses type 3 sums of squares and we're fine. But just don't have empty cells. If you have empty cells, go get more data. That's the solution. That's actually the better solution. Is just go get more data. Don't, type 4 sums of squares are great theoretically. They make up a solution, but it's not a unique solution. That's the problem. There's literally an infinite number of possible values that can go into a missing cell. So you don't want it. Questions about this empty cell, missing unequal cell sizes, etc. Oh yeah, go ahead.
How would you test us on something like this?
How would I what?
Like, how would you test us on this?
How would I test if there's, like if I had a design that had like the 2x2 with one missing?
More so like if you have a test. How are you gonna frame the question?
Oh, it would be something about empty cells. So I might ask you something like, why can't you just use type 4 sums of squares? Let's change the way I would word that. Why? It would be something like, what is a weakness of using type 4 sums of squares when you have empty cells? And that weakness is it comes up with a solution, but it's not the only solution. There's a literally infinite number of possible solutions. Something like that. I also wouldn't worry a great deal about that. This is something you should know about, but it's not something I think most of you aren't going to have have designs like that, and if you did, your honors thesis supervisor is not going to allow that to happen. If he or she did, they would get mocked for the rest of their lives by me. So they don't.
So, answer to using type 4, just don't make it necessary.
Yeah, really the best way to, if I said, how would you deal with empty cells, your best answer would be, don't have them. Collect more data. And if I said in the question, but you can't collect any more data, you can say something like, there may be other techniques, like turning it into a one-way analysis of variance. Or if you had something like, let's say a 5x5 and one column and row had missing data, just remove both those columns and then run the back point of 4x4. Right? Because if we have like a 5x5 and we have a missing cell, we can just kill a whole column, kill a whole row. You hate throwing away data. I mean, it's better than making up data, it seems to me. At least it's intellectually honest. It seems to me that estimating values for empty cells you're getting very close to doing something that I consider misconduct. Even if you are using a mathematical technique, it's still like, just don't do this. Don't do it. Design better experiments. Okay. Good questions. Other stuff. So let's stop that.